Here we have a situation where in number 1 it says a rock is kicked off a ledge and in 9.04 seconds it falls 400 meters to the bottom. Calculate the acceleration of the rock. So if we did not know the acceleration due to gravity, we could solve for it by other means. So we know that it took a time of 9.04 seconds and that it fell 400 meters. So if we were to draw a quick picture of this, we have a ledge and a rock at the top is sitting on this cliff, and then it falls 400 meters to the ground. Since it fell below its original placement or position, we know that our delta y is a negative 400 meters. We also know that since we're dealing with a rock that was pushed off of a cliff or kicked off of a cliff, the initial velocity was 0 meters per second. And we are trying to calculate acceleration. So we have our time, we have our displacement, we have initial velocity, we want acceleration. We do not have final velocity, so we're going to use the equation without final velocity. And that is our delta y in this case is equal to our initial velocity times time plus 1/2 a t squared. So then we plug in what we know. It fell 400 meters, so we know our vertical displacement is negative 400 equals our initial velocity is 0, and 0 times time is still 0, plus 1/2 of our acceleration times our time squared. So we'll take 9.04 and we will square it. Alright, so to simplify, we'll still have this 400 on the left equals 1/2 acceleration times 9.04 squared. So I'll take out my calculator, take 9.04 seconds and square it, and then I'll multiply it by this 1/2 that's out in front of the a. And I get 40.86. So 40.86 times the acceleration. So to find the acceleration, I will divide both sides by 40.86. On the right side, this will cancel out. Anything over itself is equal to 1. And then our acceleration is equal to 400, or negative 400, divided by 40.86. And we get negative 9.789, so we'll say that this is negative 9.8 meters per second squared, which happens to be the acceleration due to gravity. Alright, so now it says, using the acceleration calculated in the first section, fill in the chart to map where the object was after the given amount of time. So it wants to know after 1 second, 2 seconds, 3, 4, 5 seconds, how far has the object fallen. So we can use this same equation. Remember that since our initial velocity was 0, 0 times time is still 0, so we can completely take this part of our equation out. So our delta y will simply be equal to 1/2 of our acceleration times time squared. So we can go ahead and do this pretty quickly in our calculator. We know that 1/2 of the acceleration, since our acceleration is negative 9.8, our delta y will equal negative 4.9 times the time squared. So we will say negative 4.9 times 1 squared we get negative 4.9 meters. So I'll write that, negative 4.9 meters. Then negative 4.9 times 2 squared, we get negative 19.6. Do this with after 3 seconds, so negative 4.9 times 3 squared, negative 4.9 times 4 squared. Alright, so we get negative 44.1 and negative 78.4. Alright, then we'll plug in this last one, so negative 4.9 times 5 squared, negative 122.5. Alright, and then it wants to know the ratio to the first displacement. So we'll take negative 4.9 and divide it by itself. And we'll get 1. So here we'll write 1. Negative 19.6 divided by negative 4.9. And we get 4. Negative 44.1 divided by negative 4.9. And we get 9. Alright, so notice this is a pattern based on the time being squared. So we could predict that this is 4 squared, which is 16, and this will be 5 squared, which is 25. And let's go ahead and double check that. So 122.5 divided by the original 4.9 displacement, and we get 25. Alright. So notice here, if we double our time, our displacement is quadrupled. So it says, analyzing the data, predict and then calculate how far the rock will fall by 8 seconds. Okay, well we know that every time we double the time, we quadruple our displacement. So if we were to look at half of this 8 seconds at 4 seconds, we see that it has fallen 78.4 meters. Okay. In 8 seconds, we would anticipate falling 4 times that much. If we've doubled our time, we should quadruple our displacement. So we will write this. It's actually a way to draw it. Represent it this way. So in 4 seconds, it has traveled negative 78.4 meters. And then it will travel 4 times this much. So 1, 2, 3, 4 times as far in a total of 8 seconds. So I predict that negative 78.4 times 4 will be our total distance. So I predict that it will have fallen 313.6 meters. So let's go ahead and calculate that and see if we are correct. So we know that our equation will be delta y equals half of our acceleration times time squared. So our displacement will be equal to half of the acceleration due to gravity times our time squared, so at 8 seconds. And then we square our 8. So when we plug this into the calculator, it will be 1/2 times negative 9.8 times 8 squared, which is 64, and we get negative 13.6 meters. Alright, so just to recap, we went from, compared to 4 seconds, by 8 seconds, the rock had gone 4 times as far. It quadrupled, we doubled our time, but 1, 2, 3, 4 quadrupled our displacement. And number 4 asks us to compare the first 4 seconds that it fell to seconds 4 through 8. So in the first 4 seconds, it fell 78.4 meters. In the last 4 seconds that we are analyzing, 78.4 times 3, it fell 235.2. If we were to compare these two numbers to see how many times bigger the second section is, we would notice, so I'm taking the number, how far it fell in the last 4 seconds, from seconds 4 to 8, and dividing by the first 4 seconds, how far it went in the first 4 seconds, and I get 3. So notice it went 3 times further in the second set of 4 seconds than it did compared to the first set of 4 seconds. So go ahead and write this in as a text. The rock went 3 times farther in the second 4 seconds than in the first 4. So when we doubled our time, we quadrupled our displacement, and if we were to analyze the second set of 4 seconds, it went 3 times further in that amount of time compared to the first 4 seconds. Guys, make sure that you look on your acceleration lab. Know how you straightened your graph here, and make sure to take a special note of the shape of your graphs. Also, look at numbers 10 and 12, and look at the equations and how you got them and how you can set them equal to each other to solve for acceleration.